Dear students, today I am going to start the fourth unit of our cryptography and network security. So, in the fourth unit, we have the data integrity, digital signature schemes, and how the keys are managed. Key management, data integrity, digital signature, and key management. Generally, what is the message integrity? We know in the cryptography, we know how we are securing the message through the communication channel, how is the confidentiality of the message, what is the security level of the message which is transmitting from sender to receiver. That we have studied how we are maintaining the security, how we provide the secrecy and confidentiality. That already we have studied the different algorithms, encryption, that means the encryption and decryptions. But till now, we are not concentrate on the message integrity. What is the meaning of the message integrity? Generally, whatever we wanted to send the message from one place to another place, that message should not be altered. That message should not be changed. That is called data integrity. So the data as it is, whatever we have sent, as it is, without any modification, it should reach to the recipient. That is called integrity. So cryptography systems that we have studied so far provide secrecy or confidentiality, but not the integrity. But sometimes there are some occasions where we may not even need secrecy, but instead must have the integrity. There are some occasions where secrecy is not mandatory. Secrecy of the message is not mandatory, but its integrity should be important. For example, one person, he wanted to write a will for distributing his entire property, for assigning his entire property to a person after his death. He want to write some will. In that will, he and he declared, or he assigned, he mentioned the who is the person to hand over his property, to take over his property. So that information is in his will. Actually, if you observe, no need to keep his will secrecy. After his death, his will should be, it should be open. Then only his will is public. That means all the persons know about his will. But here, one of the important thing is, after writing his will, he he placed or he hand over his will at one of the intermediate person like lawyer. So he kept his will under the custody of some one of the lawyer. Okay, that lawyer maintained that will secretly till his death. After his death, he opened the will, and whatever the name mentioned in that will, so he will hand over his entire property to him. But here, in the meanwhile, very important thing is the message or the document, whatever in the will, should not be changed. It should not be changed. That is the integrity. So generally, this integrity can be maintained using the generally all the documents in general are maintaining with the fingerprint. One way to preserve the integrity of a document is through the use of a fingerprint. Suppose if I have prepared a document and put my fingerprint, then that is the authorized document. Suppose if anybody forgers that document, that means somebody forged my document and and he used his fingerprint. Now, if we compare the forgery document and the actual document by comparing the fingerprint, if the fingerprint which is correct, it should be matched with the forgery document fingerprint. If it is not matched, the both are not matched, we can say that is the forgery document, forgery. So one way to preserve the integrity of a document is through the use of a fingerprint. For example, if Alice needs to be sure that the contents of her document will not be changed, Alice needs to be sure that the contents of her document will not be changed. She can put her fingerprint at the bottom of the document. Suppose if anybody forged the document, then we will compare the fingerprint on the forged document and the original document. The fingerprint is matched, we can say that also original, but the fingerprint will not be matched with the original fingerprint. So like that, the integrity can be maintained by using the fingerprint. Now, message and message digest. We know message, whatever we wanted to send, that is the message. Now, the electronic equivalent of the document, electronic equivalent of the document and fingerprint pair is called as a message and digest pair. Generally, whatever we are using the terminology document and the fingerprint, the pair of these can be called as message and digest pair. Here the fingerprint is called the digest. message and digest pair, which are useful. That pair is useful to make the integrity, to preserve the integrity. So the electronic equivalent of a document, whatever it may be, and its fingerprint is the pair of message and digest. Message digest is nothing but a document with the authorized fingerprint is called message digest. Generally, to preserve the integrity of a message, to preserve the integrity of a message, the message is passed through an algorithm which is called the cryptographic hash function. Here we are using the hash function. So to preserve the integrity of the message, we should pass our message through a function, that is the hash function. If you pass a message through a hash function, then that preserves the integrity of the message. Already we know about hash function. What is the use of the hash function? Generally, for a hash function can calculate a hash value. It can calculate a hash value for its input number. Then that input number is located at its hash value. So generally hash function is useful to calculate a hash value to the input value, which is useful to preserve the message, to locate the message at a certain hash value. That is the hash function. Here also, in the case of the cryptography, we are using some of the hash functions, which is useful to calculate the hash value which is equivalent to the message. So whatever we wanted to send a message, we must send that message through a hash function. Then that hash function generates the equivalent hash value of the message. So here we can send a message. Message means document. Message is the document. We are sending that message. We are sending that message through the hash function. This is the hash function. So we are sending a message through a hash function. After that, the output of the hash function is called message digest. That means that is the fingerprint. So message with the hash function is called document with the fingerprint. Message is the document. If you send the message through a hash function, that is called message digest. Message digest means a document with the fingerprint, just in a normal, in general way. So here message, what is the relation between message and message digest? Whatever we are sending, that is called message or document. So if you send that document through a hash function, that is that document is called the document with the fingerprint, or it is also called as message digest. Here generally there are two terminologies, the two pairs, document to fingerprint. Another pair is message digest. Actually both are similar, document and fingerprint, message and message digest, both are same with a small difference. Generally our document, physical document and fingerprint means physical document and fingerprint both are linked together. That means we have prepared a document and put a fingerprint on that document. That means document and fingerprint are linked together. But in the case of electronically, our document or our message and our message digest both are unlinked separately. That means message is different and message digest is different. Both are traveled separately. So both are unlinked separately. Most importantly, the message digest needs to be safe from change. The message digest needs to be safe from changes. So what is the main difference between document fingerprint pair and message digest pair? Document and fingerprint are linked together, but message and message digest electronically they are unlinked together, unlinked separately. Now, how we are checking the integrity of the messages? Generally, to check the integrity of the message, we run the hash function and compare the new message digest with the previous ones. Generally, we have the some previous digest, and if you send the new digest, the both previous digest and current digest are same, then there is an integrity. If both are same, we are sure that the original message has not been changed. For example, see this one. Suppose already we have a message with some digest value, a message, that means it is the original. Assume this is the original document with the fingerprint. This is the original document. Previous digest means assume this is the original document with some fingerprint. Now assume this is some new message, and we have sent this message through a hash function, and this is called some current digest. Since it is the current message, through this hash function, it generates the current digest. Already we have the previous digest. This is the original one. This is the new message, new digest. Now, if we compare the current digest value and the previous digest value, if both are same, then message is not changed. If both are different, that means message is changed, then discard. So that means, suppose, assume we have the digest of the original document at the recipient side. Suppose I wanted to send a new message through an hash function, then it generates some digest value. And if you wanted to check this, the message in the current digest is changed or not, if you check the current digest value and the previous digest value, previous is original one, both are same, then message is not changed. If both are different, then message is changed. So by using this one, we can check the integrity. Generally, we have cryptographic hash functions. They must satisfy some of the criteria. Hash function needs to satisfy three criteria. A cryptographic hash function must satisfy three criteria. One of the criteria is pre-image resistance. Second one is the second pre-image resistance. Third criteria is collision resistance. That means whenever you are using the hash functions, those hash functions must satisfy three criteria. One of the criteria is pre-image resistance. Second is the second pre-image resistance, second criteria. Third one is the collision resistance. Pre-image resistance means the hash function must be a one-way function. Generally, if you use any hash function, that hash function must be a one-way function. For any given code, for any given message, H is the hash function. It is computationally infeasible to find H dash. That means, suppose if you have a message M, assume M is the message and hash function, and H of M means this is the message with the hash function called digest. So by using the H function, hash function, by using the hash function with the message M, we have created a message digest. So we have created a message digest using the hash function. So this is the message, this is the hash function, through this hash function. So H of M means this hash function H takes the message and generates the digest, message digest Y. So by using the hash function H with the input M, we have generated the message digest Y. Now send this Y to the Bob. We are sending the message digest to the Bob. In middle, some attacker or hacker also received this message digest. Assume some of the hacker received this message digest, and Y. The Y is received by some third person, Eve. Assume is Eve. Actually, this message digest Y is sent to the Bob. This is also, assume this is also received by Eve. This is the third person attacker. Now Eve received the message digest Y. By using this message digest, he tried to find the message. He tried to find that message M dash, but it is infeasible. It is not possible. It is not possible to get a message from the message digest. So given the Y to the Eve, he tried to find any M dash such that Y is equal to H of M dash. So if it is actually it is not possible. So that is the pre-image resistance. So for any third person, he cannot calculate, otherwise he cannot generate the message from the message digest. Actually, Alice, what he has done, he has generated the digest by sending message to the hash function. He generated the digest Y. Now, if the third person Eve tries to generate the message from the message digest, it is infeasible. That is called pre-image resistance. Second one is second pre-image resistance. That means in this criteria, an adversary means the attacker is provided with the value X. Here he provided the value X means message. If he provided the value X and asked to compute the X dash. So here X is the message and X dash is also message. Now if you provided the message X to the attacker, message X to the attacker, and he is asked to compute the value X dash which is not equal to X, such that he tried to, that means simple thing is Actually, X is our message, and you are asking the interviewer or adversary person or opponent person. You have given some other message to him and ask him to calculate the hash function. So if the both are the same, that means the hash function with the X and the hash function with the X dash, if both are same, then it is that means he may get the message, but it is impossible, it is difficult for the attacker to perform this computation because he don't know the hash function, he don't know the our digest. Actually, here try see this example. Alice, he want to send a message so that he combined he sent his message to the hash function. He sent this message to hash function, and we have the message digest hm. This hm is hm means message digest, m is the message. So they both send to the Eve. Now Eve received the message and the message digest, and he tried to calculate. Already assume he has provided some message. He tried to calculate using this. He tried to calculate the hash function, and if this message digest is equal to the hm, then he will send his message to Bob. But it is difficult to perform this one. This is the second pre-image resistance. Third one is collision resistance. Collision means what is in the collision in the hash table? Suppose if any two values are getting the same hash value, that means the both if we have calculated the same location for the both the values, then that is called collision. The both values should not generally two values cannot be placed at one place. That is called collision. That means collision of a hash function here. Collision of a hash function is the event when two values x and x1. Assume we have the x and x1 values. If the hash functions h of x and h of x1 and these hash values are same, then that is called collision. That means h of x gives the same value of h of x1. That means we have the same hash value. If we have the same hash value for the two different messages, that is called the collision. So see this one. Now u he has m and the hash function h of m, and he also calculated h of m dash, and if both the hash values are same, h of m and h of m dash, then that is called collision. So we should divide the collision. And we have a random oracle model for the hash functions, which was introduced in 1993 by Bellari and Roseway. Is an identical mathematical model for a hash function. Random oracle model is the identical model for a hash function. Generally, a function based on this model behaves like that. Assume we have a hash function which is working based on the random oracle model. Assume the hash function is working based on random oracle model. Now it behaves, this hash function behaves when a message of any length, has given to the hash function and is given to the oracle, the oracle creates and gives a fixed length digest, message digest. That is generally that message digest in zeros and ones. Then the oracle maintains the message and its equivalent message digest. Actually, message is any length of message, but it is by using this message, we have our oracle creates a message digest and it maintains the message and message digest pairs in the table. Like that, whenever the new messages are coming to the oracle, it generates or it creates its equivalent message digest and keep both the message and message digest in the table. Now, when a message is given, when any message is given, which a digest exists. Suppose assume Oracle has the group of messages and its equivalent message digest. Suppose now, if you give a new message or if you try to enter a message, first of all, first it checks whether any digest equivalent, whether any digest exists for this message. If the digest exists, then it will take the message digest for this new message. If the digest is not there, then it choose any one of the previous digest independently. So when a message of any length is given, the first one is when a message of any length is given, the oracle creates and gives a fixed length message digest. Then oracle maintains the messages and equivalent its digest in a table. When a message is given for which a digest exists, when a message is given for which a digest exists, the oracle simply gives the digest in the table. The digest for a new message needs to be chosen independently from all previous digests. So the hash function is working based on the random oracle model.